Good morning, good evening, good afternoon, boys and girls. Welcome to Caesar Palace channel. Today we're going to study network fundamentals. Now let's go over some of the topics that we will be covering today. Routers, switches, next generation firewalls, the tier 2, the tier 3, the spine leaf, the one, the small office, home office, also called SOHO, some of the physical connectivities, for example, we have multi-mode fiber, copper, single mode fiber connections, and component of PoE. We will also be covering the OSI model versus the TCP model. That's basically today's lesson. So let's get started. Now, the first question that might come to your mind is, so why is it so important to learn Cisco Internet working anyway? Well, networks and networking has been growing up during the last couple of years, basically during the last 20 to 30 years. And now we see automation, for example, integration of artificial intelligence going into programming in Python with networking. This is part of technology nowadays. So it is a huge deal. It is very important to learn about all the basics and intermediate level knowledge regarding the networking. Let's look at figure 1.1. It shows a basic local area network LAN connected via hop. Is not really used nowadays, but it used to be used a lot in the early 90s or in the late 90s, which is basically an antiquated device which connects wire together and typically used in Zoho networks. So keep in mind that this is a Zoho is a home office basic connectivity between two computers and the hub. And this one would be considered one collision domain and one broadcast domain. So this is a very basic Zoho network. Things really can't get much simpler than this. And yes, though you can still find this configuration in some home networks, even many of those, as well as small business networks, are more complicated today. Router switches and so Soho. Figure 1.2 shows a network that has been segmented with a switch making each network segment that connects to the switch its own separate collision domain. Doing this results in a lot of chaos. Now, take a look at what happened here. Let me change the colors. We have a hop, we have a switch, and let's just read one more time. What happened here in figure 1.2? The network has been segmented with a switch, making each network segment that connects to the switch its own separate collision domain. Okay, we will be having some collisions which can cause a problem, and we will see more about that in a moment. A switch can break up collision domains. Um, so this is great as a starting point, but I really want you to know that this network is just one single broadcast domain. This means we really only reduce our PC chaos, not eliminated it. Now, what can be some of the problems that we might encounter during this kind of topology or this type of topology? Let's go over them. Mm, okay. Too many hosts in a collision or broadcast domain, broadcast storms, too much multicast traffic, low bandwidth, adding hubs for connectivity to the network, a bunch of ARP broadcasts. Take another look at figure 1.2 and make sure you see and understand which type of network devices we have together, plugged together. Let's take another look. So we have a hub, we have a switch, we have three computers or end users as they call them. Let's continue. We make sure that you see these configurations because hubs don't segment networks. They just connect networks. Basically, it's an inexpensive way to connect a couple of PCs, which can work for really simple home use and troubleshooting, but that's about it. As our community grows, we'll need more devices to expand our networks, to segment our networks, and to have scalability. And what do I mean with scalability? It means that you have the correct topology, the correct configuration devices as your network is growing, as your company is growing. That's basically what we need, scalability. Okay, so as our community grows, we'll need to add street along with traffic control and even some basic security. We'll get this by adding routers because these convenient devices are used to connect networks and route packets of data from one network to another. Let's take a look at the next figure, figure 1.3. It depicts a router in our growing network creating an inter-network, breaking up broadcast domain. So we have basically a router and a total of two switches there. Let me just erase that. Let's go over the explanation. I love shouting, hey everyone. Sure, it's nice and quiet here. Let's take a look at the explanation about this figure. What do we have here now? Let me change colors for a moment. So, routers can create an internet network. The network in figure 1.3 is actually pretty cool. A little network. Each host is connected to its own collision domain because of the switch. And the router has created two broadcast domains. So we have one over here. This is the first broadcast. And one over there. You see it? That is the second broadcast. What happened now? Let me just change back to red. So now Sally is happily living in peace in a completely different neighborhood, no longer subjected to Bob's unnecessary shouting. If Bob wants to talk to Sally, he has to send a packet for a destination address using her IP. He cannot broadcast for her. And what do I mean with broadcast? It's basically that the router sends a notification to everyone. Let's say, are you there? Are you there? That's basically what I mean with broadcast. The router sends a communication to everyone, like asking, are you there? And the person that he's trying to contact will reply, yes, I am here. We will see more about that later in a moment. Okay. So routers connections use wide area networks. These are from one ISP internet service provider to another. Wide area networks cover more space. It will be, let me just set an example. Two offices for Verizon. They connect together via an ISP, which is in this case also Verizon Business. And they start doing the first one communication between two cities, let's say Dallas and Chicago. they connect through Verizon services. That's an example of wide area network. Okay, let's take a look at figure 1.4. What do we have here? Think. We have something that is, and we will see more about this later on, MAC address table. The MAC address is layer 2. Those MAC addresses are usually like identifications for the computer's port and connection. We will see is an hexadecimal value, as you can see in this example. Let's go ahead and go with the explanation. Let me just stop sharing the video and we can focus on the content. So the real business is all about location, location, and location. And it's the same for layer 2 and layer 3 devices. Although both need to be able to negotiate the network, it's crucial to remember that they are concerned with very different parts of it. So layer 3, routers. Layer 2, switches. That's about it, the way that they behave. And we will go more into detail about the different layers and the OSI model later on, probably in this video or another future video. Okay, so let's go with this explanation. After a filter table is built on a layer 2 device, it will forward frames only to the segment where the destination hardware is located. If the destination device is on the same segment as the source host, the layer 2 device will block the frame from going to any other segment. If that destination is on a different segment, the frame will be transmitted only to that segment. This is called transparent bridging. Now, let's go ahead and move to next generation firewalls and talk a little bit about them. Today's networks definitely need security. And as our network grows, we'll need to increase protection for it. These are new devices out that actually seriously help us. They help us to secure our networks, providing solid security. Next generation firewalls, NGFW, providing full layer 7 inspection. However, it's totally true that every company, including Cisco, markets their devices like this. Let's take a look at figure 1.5. The picture devices in a small network and how a basic firewall or NGFW can be placed to provide security in your network. So you see the firewall here. It can be, we have different branches. For example, Palo Alto. We have Cisco. We can have Fortinet. And so on. Maybe I'm typing it. Yeah, Fortinet. So those are just examples of some companies that provide these security devices in our network. Now, what do we have here? This is the physical components of a network. We have a printer, a server, desktop, an IP phone. We have 2 switches, 1 router, 1 firewall, and the connection to the ISP, Internet Service Provider. Basically, that's what we have here. Now, a firewall or NGFW design can be pretty complicated, but we don't need to get into the weeds here. Since this is a Cisco book, we're going to stick with Cisco technologies in our firewall. Cisco has a next generation firewall, NGFW, called Firepower. And they were acquired from a company called SourceFire in 2013 or 2013. Now, understand this is going to be a brief introduction. We can go deeply and study these topics in in CCNP security level, CCNP security, but we are just talking about the basic and fundamentals regarding the firewalls. So let's start by defining uh, NGFW and what it has to do with intrusion prevention systems, IPS. NGFW are considered a third generation firewall technology that provides full packet reassembly and deep packet inspection to and through layer 7. So, what are some of the advantages or functionalities of a firewall? In this case, this generation firewalls. They can be a router and a switch. It means we have compatibility with layer 2 and layer 3. Oh, they help us with malware inspection capability and packet filtering with IPS, provide network address translation, NAT, and we will go over what it means and how does it work. But basically, it's translated private IP address into public IP address, so we have connection to the internet. For now, let's just stick with that definition. Permit stateful inspection, permit virtual private networks, provide URL, and application filtering, implement QoS, third-party integration, support REST API. That's not a short list, and in items in it are all absolutely required because NGFWs must pack a powerful security punch in order to lock our modern network down tight. Figure 1.6 shows a Cisco firepower blocking an attacker trying to exploit a vulnerability on my network, which IPS stopped dead. The red line on top indicates all the attacks, and the blue line is for the data. Wow, that's a lot of attacks. Look at that. So remember, the red one represents the attacks. And do you guys remember what is the blue line? It is data. Data. Now let's dig into those attacks. We'll see how a Cisco Firepower NGFW came to the rescue, blocking all those attacks via my IPS policy, as shown in figure 1.6. Figure 1.7 displayed some of the events that were caught by Cisco Firepower. We have some server potential vulnerability attacks and connections there. Cisco IPS policy to the rescue. As you just get to know this information and becomes familiar with it, you start learning about all this vocabulary about cyber attacks, vulnerabilities, packets. But do not worry about. By the time you continue learning through this course, you will be more familiar with them and it will be easier for you to understand these topics. Now, let's go with network topology architecture. We're not going to go too deep into this. What is this one? Event priority, high. Figure 1.8, Cisco firepower IPS policy dropped by the bad guys packets. NGFW perform a deeper inspection compared to your traditional firewall. For instance, a stateful ASA that Cisco is moving away from is being replaced with new firepower threat defense FTD devices, which are true NGFW devices. Okay, so let's go over some topology. What do we have here? We have something that is actually very important and is called the Cisco hierarchical model. Let me just, if I can go back. I want to show you there. We have the core, we have the distribution, the core, the distribution layer, and the access layer. All of them are part of the Cisco hierarchical model. Let's study about those a little bit. So the core layer is literally the core of the network. At the top of the hierarchy, this layer is responsible for transporting large amount of traffic both reliably and quickly. The prime purpose of the network core layer is to switch traffic as fast as possible. And you can see it here. We have the backbone routers devices connected, and they are located at the core layer. We have a couple of layer 3 devices in the distribution layer and layer 2 devices in the access layer. Let's try to understand a little bit about the use. For the distribution layer is sometimes referred to as the work group or aggregation layer. Is the communication point between access layer and core. The primary functions of the distribution layer are to provide routing, filtering and one access to determine how packets can access the core if needed. And finally, we have the access layer. It controls users and workgroups, and that's basically the connection of layer 2 devices and end user devices. That's what we have here. We have servers, we have computers, we have layer 2 switches. Let's go over the definition one more time. The access layer controls user and workgroup access to the internet network resources and is sometimes referred to as the desktop layer. The network resources most users need are available locally because the distribution layer handles any traffic for remote services. Okay, I will share this book so you can look into it and read deeply. If you take a look at this, we have like a physical graphic where you can see the core, the access layer, the aggregation devices, and so on. Let's go over the definition of this one. This is a real-life collapse core tier 2 image or two-tier image. Here you see the core and distribution are also called aggregation, are both running on the same large enterprise switch. The access layer switches connect into the enterprise switch only in the defined aggregation ports. This design is much more economical and it's still very functional in a campus environment where your network may not really grow significantly larger over time. It's known as a collapse core and refers to a design which the distribution layer and core layer functions are implemented by a single device. The big reason the collapse core design exists is for reducing network costs while maintaining most of the benefits of the three-tier hierarchical model. Switch leaf. I've been writing about Cisco three-tier network design for a long time, and I just did again. But today's data center demand a new design, and one was finally created that works really well, called leaf and spine topology. This design is pretty old, as this writing is just not decades old. Here is how it works. Your typical data center has racks filled with servers and the leaf and spine design. There are switches found at the top and end of each rack that connects these servers, which a server connecting into each switch for redundancy. People refer to this as a top of a rack TOR design because the switches physically reside at the top of the rack. This picture, figure 1.11, it pictures a top of rack network design. Okay, you can see basically the different devices and equipments and the cable connectivity, everything together in a rack. Top of the rack design, these door switches act as the leaves within the leaf and spine topology. The ports in the leaf switches connect to a node. Example, a server in the rack, a firewall, a load balancing appliance, and or a router leaving the data center as well as to the spine switch. Check out figure 1.12. We have the Cisco Nexus, you have the Cisco Nexus series, and you have the rack for all the different equipment. Let's go over the explanation on this one. Figure 1.12 spine and leaf design. You can see each leaf switch connecting every spine switch, which is great because it means that we no longer need a gazillion connections between switches. Keep in mind that the spine only connects to leaf devices, not to servers or end devices. And interestingly enough, when you connect your Tor data center switches in a leaf and spine topology, all of our switches are the same distance away from one another, single switch hop. So let's begin with one basic by asking, what's the difference between wide area network and local area network? Clearly, there is a difference factor. And let me just stop the camera for a moment so we can focus in the content. So local area network is your local area network at your house. It's pretty much small, an office with a very few equipment and routers. Wide area networks is when we connect different cities from one city to another. Let's say in Costa Rica, for example, we have a city called Heredia and one city called San Jose. We're connecting San Jose to Heredia. Let's say in the US, you are connecting, for example, Charlotte, North Carolina, with another city in South Carolina, for example. That's basically what a WAN connection is. Wide area networks connecting different cities. A major distinction between WAN and LAN is that while you generally own a LAN infrastructure, you usually lease a WAN infrastructure from a service provider. Modern technologies sometimes blur this characteristic somewhat, but this factor it's still fits neatly into the context of Cisco exam objectives. Defining WAN terms. Before you run out and order a WAN service type of provider, you really need to understand the following terms that service providers typically use. Okay, so this is a topology and these are some of the WAN terms. We have CO. What do you think it means? Or what does it stand for? Central office. This point connects the customer network to provider switch network. Make a mental note that a central office CO is sometimes also referred to as a point of presence, POP. Okay, so we have the demarcation point, the loopback, the local loopback, the CSU, DSU, the CPE, customer premise equipment, the corporate office, and that's basically it. So let's go over those terms. Customer premise equipment is equipment that's typically owned by the subscriber and located on the subscriber's premises. CSU, DSU, Channel Service Unit, Data Service Unit, CSU, DSU, is a device that's used to connect a DTE to a digital circuit like T1, T3 line A device is connected, considered DTE, if it's either a source or destination for digital data. For example, PC, PC servers and routers. Although the CSU DSU connects to the service provider's infrastructure using a telephone or coaxial cable like a T1 or E1 line, it connects to the router with the serial cable. The most important aspect to remember for the CCNA objectives is the CSU DSU provides clocking of the line to the router. Figure 1.13. You can see over here the CSU DSU represented by this box. Demarcation point. The demarcation point demarks, for short, is the precise spot where the service provider's responsibility ends and the CPE begins. It's generally a device in a telecommunication closet owned and installed by the telecommunications company telco. It's your responsibility to cable extended demarc from this box to the CPE, which is usually a connection to a CSU DSU. Local loop. The local loop connects the demarc to the closest switching office, referred as the central office. So you can see the demarcation point over here and the local loop. It's connecting close to the service provider. We have the central office, also called the point of preference. We already went over it. Basically, this point connects the customer's network to the provider switching network. You can make a mental note. Remember that it's also called POP or point of presence. Finally, we have the toll network. A toll network is a trunk line inside a one provider's network. Let me see if we have that over here. I see it there, the toll network. There you go. So, what is it? A toll network is a trunk line inside the one's provider network. This network is a collection of switches and facilities owned by the Internet Service Provider ISP. Now, make sure that you're comfortable with these terms, what they represent, and where they are located as shown in figure 1.13, because they are key to understand WAN technologies. Even though I am not employing this device, optical fiber converters, optical fiber converters are used to where the fiber optic link terminates and convert optical signal into electrical signals and vice versa. You can also implement the converter as a router or switch module. So, one connection bandwidth. Let's go over some additional terms that we need to be aware of and understand. Okay, so the first one is digital signal or DSO. This is the basic digital signaling rate of 64 kbps, equivalent to one channel. Europe uses the EO or Japan uses the JO to reference the same channel speed. Typically, to T-carrier transmission. This is the general term used by several multiplex digital carrier systems and is also the smaller capacity digital circuit. DSO equal one voice, one data line. T1 refers to as a DS1. A T1 comprises 24 DS0 circuit bundle, together for a total bandwidth of 1.544 Mbps. E1, this is the European equivalent of a T1, and this one comprises 30 DS0 circuits bundled together for a bandwidth of 2.048 Mbps. T3 referred to as a DS3 or T3 comprises of 28 DS1s bundled together, or 678 DS0 for a bandwidth of 44736 Mbps. Now, you're talking about all these T1, E1s, T3, but do you guys remember the first lesson that we have about submarine cables? They are going under the sea. These are them, basically. These are the different connections and different capacities that we have covered under this, going under the sea. Basically, so you can have a visual image of what we are talking about right now, and you don't get lost. OC3, optical carrier OC3 uses fiber and is made up of 3 DS3s bundled together. It's made up of 2016 DS0s and available at total bandwidth of 155.52 Mbps. OC12, optical carrier 12, is made up of 4 OC3s bundled together and contains 8064 DS0s for a total bandwidth of 622.08 Mbps. OC48, optical carrier 48, is made up of 4 OC12 bundled together and contains 32,256 DS0s for a total bandwidth of 2,488.32 Mbps. And those are basically the different WAN connections. Now, how do we apply this in real life? Well, we have a bridge conference call, and we have 2 level 2 network engineers and 3 level 3 network engineers troubleshooting a network problem. At the end, they figure out the OC12 is down, and they have to do a maintenance and send submarines and fix the cable under the sea. And that's a little bit of an example how this apply in real life, just for you guys to have a knowledge. If you're working ever on a network operations center or a similar place, you have an example of a real life scenario. We study a little bit about physical cables on the first lesson. Let me see. Okay, this is the important part. 10 base T. 10 Mbps using category 3 unshielded twisted pair. UTP wired for runs up to 100 meters. Unlike with 10 base 2 and 10 base 5 networks, each device must connect into a hub or a switch. You can only use one host per segment or wire. It uses RJ45 connector. Okay, what about 10 base TX? That's mostly commonly known as fast Ethernet, and is also RJ45 connection covering 100 meters long. Now, what is the difference between the first one and the second one, you may say? Well, let's take a look at this one. This one is the fast Ethernet, and this one is just unshielded twisted pair cable, UTP. Those are different kind of physical cables with different capabilities. This is also called 6 UDP 2 pair wiring, and we can use a physical star topology or logical bus. The other one is multi-mode fiber 100 base FX. And you can see the micron multi-mode fiber. We're talking about fiber cable is a little bit more stable when we're talking about this kind of connections. And now we're covering a total of 412 meter long. 1000 base CX is copper twisted cable. And basically it covers 25 meters. 1000 base CX. 1000 base T, this one covers 100 meters long, up to 1 gigabit, 1 Gbps is Cat5 4 pair UDP wiring up. And now let's go with this one, 1000 base SX. This one is also fiber cable. You can see more extension of connectivity in distances, and you can cover as long as 550 meters total. You can see the micro core connection. We're talking about fiber, of course, and the capacity to cover 1 gigabit Ethernet connection. We have 1000 LX, 1000 base LX, fiber mode fiber, single mode fiber that uses 9 micro core, 1300 NMS layer. This one covers up to 3 kilometers. 1000 base CX. This one covers 70 kilometers or 43.5 miles if you are in the US. They use more miles than kilometers. It's also known as, we have the 1000 base CX, but we have the standard for gigabit Ethernet communication. Is the ordinary single mode fiber optic cable, and you can cover more distances. And finally, you have the 10G base T, also 802.3.AN. This one is a standard proposed by IEEE committee. And basically, you are talking about RJ45 cable, Ethernet LAN connection, 100 meters distances for LAN wiring. Those are the most important cables. Probably there are more, but we have covered the most important distances and cables, so you have a basic understanding and knowledge about them. Okay, let's go with the Ethernet cable. Ethernet cabling. As discussion about Ethernet cabling is an important one, especially if you are planning on taking the Cisco exams. You need to really understand the following 3 types of cables: a straight through cable, crossover cable, rollover cable. We will look at each in the following section, but first, let's take a look at the most common Ethernet cable used today. Ethernet cable is the Cat5 category 5 enhanced unshielded twisted pair UTP cable. You can see it in the figure 1.14. Cat5 enhanced UTP cable can be handled speeds up to a gigabit with a distance of up to 100 meters. Typically, we use this cable for 100 Mbps and category 6 for a gigabit, but the category 5 enhanced is rated for gigabit speeds, and category 5 is rated for 100 Gbps. A straight-to cable. The straight-to cable is used to connect the following devices: host to switch or hop, router to switch or hop. Okay, in this figure, you can see the way that they are connected. 4 wires are used in a straight-through cable to connect Ethernet devices. It's relatively simple to create this type. And figure 1.15 shows the 4 wires used in a straight through cable. You can see green, green, yellow, and yellow. And the transmissions happen on the different pins. You can see pins 1 and 2 in the host, 3 and 5, transmitting information, receiving information, receiving information, transmitting information. Also, we have the same pins here, 1 and 2 and 3 and 6. Notice that only pins 1, 2, 3, and 6 are used just to connect them. And just remember that this will be 100 over 1, it will be 10 over 100 Mbps, Ethernet only cable, and wouldn't work with gigabit voice or other LAN or WAN technology. The crossover cable can be used to connect these devices, switch to switch, hop to hop, host to host, hop to switch, router to host, router to router. The same four wires used in the straight-through cable are used in this cable. Just connect to different pins. You can see that in the first part we have the receiving pins 1 and 2, and in the second switch or device you have transmitting on pins 3 and 6. That is the crossover Ethernet cable. Notice that instead of connecting 1 to 1, 2 to 2, and so on, here we connect pins 1 to 3 and 2 to 6 on each side of the cable. Figure 1.17 shows some typical uses of straight-through and crossover cable. We have the crossover cable connecting switch to switch, router to router, router to PC. And we have the straight-through router is actually a PC to a switch, a router to a PC. Let me just erase this information real quick. I think we have pretty much covered everything that you need for today's lesson. Let's describe this image to close the lesson, and we will cover the OSI versus TCP model in the next lesson, so we don't create a lesson too extended. The crossover example in figure 1.17 are switch port to switch port, router Ethernet port to router Ethernet port, and router Ethernet port to PC Ethernet. So basically, it is explaining the same, that if you're working with, for example, you're working with a straight-to cable, you can have PC to switch or router to switch. If you're working with crossover, you can have switch to switch, router to router, or router to PC. Now, with technologies nowadays, this is what happened. Give me just a moment to explain. Some devices, routers and switches identify the connection, and it doesn't matter if it is crossover or straight to cable. It doesn't matter because technology is moving with big steps, advanced steps. So please be aware about that. But these are the fundamentals of networking, and we have to be aware and familiarize with them. So I think this is pretty much everything. Let me see, what else do we have here? Oh, we're missing some important information there. UTP gigabit wiring 1000 base T, and you can see the figure 1.18 that is showing the connection, how everything is plugged together. Fiber optic. Okay, the fiber optic cabling has been around for a long time and provides some solid advantages. This is the way that it's created. It's basically with a core, a cladding, and a buffer, and it covers more distances and with more stability per se. It will be a more stable connection, more reliable connection than the current Ethernet RJ45 connection that you have. So when you have the fiber, you have a more reliable and trusted connectivity, more stable connectivity. That's basically the fiber. It is important that you don't look at the eye because it has like a laser per se, and it could be leave you blind. So be careful if you're working on this ever in the field. So you don't have to look at the light, at the laser light, because it's dangerous. So that's a little bit about the the connection, the fiber optic connection. In this picture example, we have the 9-micron core, and the example of this one. Let's go over the description. Typical fiber cable dimensions are on 10 to the power of -6 meters, not to scale. So here the cladding of 125 microns, which is actually fiber standard that allows manufacturers to make connections for all fiber cables. The last piece of this cable is the buffer, which is there to protect the delicate glass. These two major types of fiber optics, single mode and multi-mode, shown in figure 1.20, shows the difference between the multi-mode and the single mode. You have the multi-mode and the single mode connection. Power over Ethernet. This is usually used for IP phones where you have connections to switches and you receive the power through this technology via the Ethernet connection cable. So the power over Ethernet technology describes a system for transmitting electrical power along with data to remote devices over a standard twisted pair cable in an Ethernet network. This technology is useful for powering IP phones, voice over IP or VoIP, wireless LAN access points, network cameras, remote network switches, embedded computers, and other appliances. Just remember, these are the ones that we usually use for phones to receive data and electrical power. That's the most important part here. Summary of the chapter, we have covered the difference between wide area network, local area network, a little bit about protocols that we will cover more deeply in the next lesson or chapter. We study a little bit about the firewall, the architecture of Cisco devices and equipment, and the cables, the different cables and connections that we can have. So that will be everything for today's lesson. I hope that you have liked this learning experience, this lesson. You have collected as much as possible. Through the course that I will be selling in Hotmart with all these labs and these books and the different topics that we will cover during these CCNA certifications, I will leave this information. I will leave the books. I will leave the websites. I will leave all the information that we will be using along during the course. In the YouTube channel, I'm just sharing the video, the knowledge. But if you go and buy the Hotmart course, and I will share that with you later on, as soon as it is completed in the next couple of weeks or months, you will have a chance to get a certificate and have all the knowledge all plugged together in a single platform per se. So my name is Cesar. It's been a pleasure working with you guys today. We have a very, very amazing lesson with a lot of learning, a lot of knowledge. It was very dynamic. I like it. So take care, boys and girls. Until next time, I see you around.